In this video we will see how we can follow this rule using Java code. This is called exception handling. Exception handling is the mechanism to reroute your program if an exceptional situation arises, so that the program continues its normal execution without being interrupted. Exception handling in Java is managed by 5 keywords: try, catch, finally, throw, and throws. I'm using the same example from the last video. We have person class having a constructor, which might result in one checked or one unchecked exception. On the right picture, we are using the try, catch, finally construction to handle the exception. This is just an overview to briefly take a look at what the whole process looks like. Let's go now and revisit each of those keywords and see what exactly is their purpose. We will start with the throw and throws keyword. Those keywords are used when we want to throw an exception, because before there is the need to catch an exception, some code somewhere in the program must throw one. Exception may be thrown anywhere in the code. The throw keyword in Java is used to explicitly throw an exception from a method or a block of code. We can throw both types of exceptions, checked and unchecked. The throw keyword is mainly used to throw our own exceptions, rather than built-in Java exceptions. The syntax is as follows: throw an exception instance. Usually, we create the instance of the exception by the time we throw it, but as you will see later in this chapter, this is not the only option. The throws keyword is used in a method's signature to indicate that this method might throw one of the listed exception types. The caller of these methods must use the catch or specify rule for any checked exceptions. The syntax is as follows: access modifier, return type, name, followed by arguments list, and then the throws clause, which is using the keyword throws and an exception list. The throws clause of a method may contain one or more exception types, separated by a comma. Only checked exceptions must be specified in the throws declaration of the method's signature. Because of their nature, unchecked exceptions doesn't need to be specified, as they are not a subject of the catch or specify rule. Again, we have the same example. Look at the throw statement at line 10 and 15. We throw two exception types. As already mentioned, one of the types is unchecked, the other is checked exception. As you can see in the throws clause of the constructor, we specify only invalid person argument checked exception, which is, as you may guess, a checked exception. We could have listed the unchecked exception as well, but it's unnecessary. More to that later. Now, let's see how we can remove the compilation error when we try to use the constructor of class person. As I already mentioned, exception handling in Java is done by the usage of the keywords try, catch, and finally. Let's look at line 6, where we want to create an object of type person. We have a compilation error saying unhandled exception type invalid person argument checked exception. Java proposes us two quick fixes, which are actually our only options. If a method we are using may result with a checked exception, we must follow the catch or specify rule. If we decide we want to specify the exception, we can just add a throws clause to the method that is calling the problematic method. In our case, we can add the throws clause to the main method. But if we decide to catch the exception, we can use the following construction. We will go and explain each of those keywords one by one, how they are used, when and why, so don't be scared. Try is used to specify a block of code where we should place the code which may result in an exception. If exception occurs, the remaining code in the try block is skipped. We can't use try block alone. it must be followed by either catch or finally. Catch is used to specify a block of code which should be executed if an exception of a certain type occurs. Every catch block must have at least one type of exception which should expect to catch. A try block may have more than one catch blocks following it. A catch block may be followed by a finally block. As you can guess, you can't use the catch block alone. And finally is used to specify a block of code which will be executed no matter if an exception has occurred or not. It's usually containing some important code which execution must be guaranteed either way. The finally block is not mandatory. As you can see, we've enclosed the constructor of the person class in a try block, followed by a catch block which is catching invalid person argument checked exception. We have a block of code in which we can decide what to do with that exception. For example purposes, we also have a finally block at the end, where we can put some cleanup code, or whatever we want for that fact. Let's examine the finally clause and the workflow of a try-catch finally construction for that fact. The finally clause is always executed, no matter if an exception occurs or not. We can't use finally clause without at least a try block. You also can have only one finally block in a single try-catch finally construction. If we have try-catch finally construction, there are three ways things could go. Scenario 1. The code in the try block doesn't throw an exception, meaning all the code in the try block will be executed. Then catch clauses will be skipped and the finally block will be executed. Scenario 2. The code in the try block results in an exception, which means the code in the try block will be executed to that point where the exception is thrown. The rest will be skipped. The exception is caught in a matching catch block. If the catch block doesn't throw an exception, all its code is executed, and then the finally block will be executed. If the catch block throws an exception, the code in the catch block will be executed to the point where the exception occurred. The finally block will be executed, and the program will probably end abruptly. Last option. The code in the try block results in an exception which is not caught, but any of the catch blocks, if any. This means the code in the try block will be executed by the point where the exception is thrown, and then directly the finally block will be executed. In all our scenarios, finally block will be executed, meaning it's the perfect place to clean up after us if we have some additional resources or something else that must be always executed. Let's see in action all the situation we've described. We have walk method in the class person. That method can throw person exception, which is checked exception, and runtime exception, which, as you know, is unchecked exception. In the exceptions demo class, we have created a person object on which we call the method walk. We've also placed some print statements before and after the walk method to see what will be printed in which situations. We've also taken care to catch the checked exception person exception, and for demo purposes we again assume that there is a 50% chance a new exception will be thrown in the catch block. All of those have their own print statements to follow the progress. In the finally block we print one more statement, and after that one more. I've marked every print statement with a number just to be more precise. In option 1, the code in the try block doesn't throw an exception, meaning all the code in the try block will be executed. Then catch clauses will be skipped, and then the finally block will be executed, and what is after it. As you can see, only steps 1, 2, 5, and 6 will be executed. As no exception is thrown, the code in the try block is executed, no code is executed from the catch blocks, then the finally block is executed, and whatever is after the finally block, which is one more print statement. That was the first scenario. Let's see our second scenario. We will split it into two mini scenarios as this is the case. The code in the try block results in an exception, which means the code in the try block will be executed to the point where the exception is thrown. The rest of it will be skipped. The exception is caught in a matching catch block. If the catch block doesn't throw an exception, all its code is executed, and then the finally block will be executed. We will stop here and examine the code flow. Print statements 1, 3, 4, 5 and 6 will be executed. The first print is always executed, and when an exception is thrown from the try block which is catched, we go to the catch block. We execute both print statements as no more exceptions are present in the catch block, and then the code continues normally until the end of the program, executing the finally block and whatever is after it. The second mini scenario is if the code in the catch block throws an exception. The code in the catch block will be executed to the point where the exception occurred. The finally block will be executed and the program will end abruptly, meaning only steps 1, 3 and 5 will be executed, as once the code in the catch block throws an exception, there is nothing left to handle that exception, so the program is ending abruptly, executing only the code in the finally block. One point here. Don't mind the order of the print statements from the picture I've attached. This is not related to the workflow of the program. Lastly, we have our third scenario. The code in the try block results in an exception which is not caught by any of the catch blocks. This means the code in the try block will be executed by point where the exception is thrown, and then directly the finally block will be executed. So in our example, runtime exception will be thrown, which is not handled by us, resulting in only steps 1 and 5 to be executed. Again, the order of the printing is not really synchronized. We will learn why this is the problem and why it might happen when we reach the chapter for multi-threading. This was all about exception handling in Java. We've seen some advanced stuff as well, so good job. If it seems to you that I'm repeating some stuff a couple of times, which is unnecessary, don't think so. I'm doing that because exception workflow may be confusing and I want you to not miss a thing. See you in the next video where we will learn some more advanced technique to handle exceptions.
For more details, check the link in the description. Learn with Whizlabs. Success certified.